I'm using LassoLarsIC, a machine learning algorithm in Sklearn, to choose the best model for linear regression. LassoLarsIC is specifically designed to handle situations where we want to select a subset of features from a larger set. I have a dataset with 1,000 samples and each sample has 100 different characteristics or features. Think of it like 1,000 patients each with 100 different health measurements. I'm using the Bayesian Information Criterion, BIC, to guide LassoLarsIC's selection of features. BIC helps to balance the goodness of fit and the complexity of the model. The goal is to find a balance between accuracy and simplicity so the model isn't too complex and risks overfitting the data. After running LassoLarsIC, I found that only 15 out of the 100 features were selected as important for the best model. This shows that many features had little impact according to the BIC criterion. This is true. BIC prefers simpler models, meaning models with fewer features. LassoLarsIC, using BIC, found a sweet spot. A model that's accurate enough but not overly complex. Partially true. LassoLarsIC uses the magnitude of the coefficients which shows the feature's importance. However, BIC is the ultimate decider and might disregard some features despite large coefficients, for the sake of a better overall model. This is exactly right. LassoLarsIC tries out many different combinations of features and picks the one with the lowest BIC score which shows the best balance between complexity and fit. Likely true. AIC, another model selection criterion, doesn't penalize complexity as strongly as BIC. Therefore, if I used AIC, I would probably end up with a more complex model, using more of the 100 features. I see this statement as partially true. LassoLarsIC uses the lasso method, which indeed prioritizes features with larger coefficients. However, the final selection isn't solely based on coefficient size. The Bayesian Information Criterion, BIC, ultimately determines which feature subset provides the best balance between model accuracy and simplicity. It's like choosing ingredients for a recipe. You might prefer certain ones because of their flavor, coefficientsize, but the final combination depends on the overall recipe's goal, BICSCORE. This statement is completely correct. That's exactly how LassoLarsIC with BIC works. It systematically explores different feature combinations, calculating the BIC score for each, and finally selects the model with the lowest BIC, indicating the optimal trade-off between how well the model fits the data and the number of features it uses. I'd say this statement is highly probable. The Akaika Information Criterion, AIC, and BIC are both used to compare models of different complexities. But AIC penalizes complexity less harshly than BIC. Therefore, with the same data, AIC would likely prefer a more complex model, a model with more features, to achieve a slightly better fit. Think of it as a risk-reward decision. AIC is willing to accept slightly more complexity for potentially better accuracy. I have a dataset. It contains information about 100 different things, features, and I've measured those things on 1,000 different samples. Think of it like 1,000 patients, each with 100 different medical measurements. After running the LassoLarsIC model, I discovered that only 15 of the original 100 features are actually important for predicting whatever it is that we're trying to predict. LassoLarsIC did the selection for me. The model decided that only 15 of the 100 initial features are necessary. The algorithm did this all by itself. It means that the other 85 features probably aren't very useful for prediction. This simply means that the dataset has 100 features and 1,000 samples. This is very important to define the scope of the dataset. Each sample has 100 features. The model selected the 15 features by finding the combination that gave the lowest Bayesian Information Criterion, BIC, score. The BIC score is like a judge that balances how well the model fits the data with how many features it uses. A lower score is better. It likes simple models but still wants them to be accurate. I used a LassoLarsIC model with the BIC criterion for model selection. LassoLarsIC is a clever technique that does two things. First, it uses the least absolute shrinkage and selection operator, lasso, method which basically shrinks some of those coefficients to zero, making the model more simple and focusing on the most important variables. Second, I've asked it to select the best model based on a metric called the Bayesian Information Criterion, BIC, which helps in choosing the simplest, yet accurate, model. This explains the overall task, selecting the most effective subset of variables, features, using the LassoLarsIC method, a technique designed to balance prediction accuracy with model simplicity. This is what I'm doing with my data. I'm using LassoLarsIC, a tool from Sklearn, to pick the best model for a linear regression problem. Think of it as a smart feature selector for my model. LassoLarsIC, which stands for Least Angle Regression with Lars Algorithm and Information Criterion, uses a clever algorithm to find the best balance between how well the model fits the data and how complex it is. I have a dataset with 1,000 different examples and 100 different characteristics describing each one. This is the information LassoLarsIC will use to find the best model. I'm using LassoLarsIC with the Bayesian Information Criterion, BIC. BIC helps me choose the best model by considering both how well it fits the data and how many features it uses. Simplicity. A simpler model is preferred since it's easier to understand and less prone to overfitting. After running LassoLarsIC, I see that it selected only 15 out of the 100 features. The algorithm has determined that these 15 are the most important ones for building the best model based on the BIC criterion. I have 4 multiple-choice options to determine which statements accurately describe the results from my feature selection process. This tests how well I understand LassoLarsIC and the BIC. I'm using LassoLarsIC, a scikit-learn tool, to pick the best features for a linear regression model. It's like choosing the most important ingredients for a recipe. After running LassoLarsIC, I selected only 15 out of 100 features. Think of it like choosing only 15 of 100 spices to make my dish. LassoLarsIC, guided by the Bayesian Information Criterion, BIC, decided that only 15 features were truly necessary. The rest are probably less important for the model. BIC is a mathematical way to choose the best model by balancing its accuracy and simplicity. It helps me avoid overfitting, like using too many spices, which might only work for that specific recipe, but not generalize well for others. I used LassoLarsIC with BIC as the decision-making criterion. LassoLarsIC is a specific algorithm that combines lasso regression, which helps select important features, and a model selection criterion such as BIC. So, BIC acted like the final judge, selecting the model that balances fit and simplicity. I'm using LassoLarsIC, a scikit-learn tool, to pick the best model for a linear regression problem. Think of it as a smart tool that helps me find the best combination of features to predict something. LassoLarsIC is particularly cool because it helps select only the important features, ignoring the less relevant ones. My dataset has 1,000 samples, think data points, and each sample has 100 features, think different pieces of information about each sample. I need to select the best features to use in my prediction model. I use LassoLarsIC with the Bayesian Information Criterion, BIC. BIC is a fancy way of measuring how well my model fits the data and how complex it is. The goal is to find a good balance, a model that fits well but isn't unnecessarily complicated. BIC tells LassoLarsIC to use BIC for this balance. LassoLarsIC is doing its feature selection magic. It's deciding which of those 100 features are truly important for my predictions, and which ones I can safely ignore. After running LassoLarsIC with the BIC, the algorithm decided that only 15 of the 100 features are essential to build an accurate prediction model. This is a significant reduction in complexity. If I had used the Aikaika Information Criterion, AIC, instead of BIC, I would likely end up with a model that uses more than 15 features. AIC and BIC are both ways to balance model fit and complexity, but AIC is less strict about complexity. It is more tolerant of adding extra features than BIC. The BIC setting tells LassoLarsIC to try many combinations of features and choose the combination that produces the lowest BIC score. The lowest score means the best balance between good fit and low complexity. LassoLarsIC uses the absolute values of the coefficients to find important features. Think of coefficients as numbers that tell you how much each feature influences the outcome. Features with large coefficient values are considered more important. However, it's crucial to remember that it's the BIC that makes the final decision about which features to include. BIC prefers simpler models, fewer features, all other things being equal. LassoLarsIC, using BIC, selected only 15 features, striking a balance between how well the model fits the data and how simple it is. That's pretty neat. I'm using LassoLarsIC, ASCIKITLEARN tool, to pick the best model for my linear regression. It's like choosing the best recipe from many options, based on how well it predicts the final outcome. LassoLarsIC is particularly clever because it helps select only the most important ingredients, features, while ignoring less relevant ones. I'm using the Bayesian information criterion, BIC, to guide the model selection process. BIC helps me balance the model's accuracy in predicting my data with the complexity of the model itself. Think of it like this: a simpler model is preferable to a complicated one, as long as the simpler model is not too inaccurate. The BIC setting ensures LassoLarsIC uses BIC for this balance check. I have a dataset with 100 different characteristics, features, for 1,000 different items, samples. For example, if I'm predicting house prices, features might be square footage, number of bedrooms, location, etc., while each sample represents a different house. After LassoLarsIC has selected a model, I evaluate it using the BIC. A lower BIC score is better because it means I've found a simpler model that still predicts well. It's a trade-off. The model should be simple to avoid overfitting, but still capable. After running the LassoLarsIC with BIC, my model only uses 15 of the 100 features. This means 85 features were deemed unnecessary for accurate prediction by my model. This is expected because LassoLarsIC seeks simpler and more efficient models by removing redundant features. The result of the model selection process is a model that uses only 15 of the initial 100 features. This highlights the power of LassoLarsIC in selecting a parsimonious model using the BIC.